solve this differential equation, we have to prove that it's an exact differential equation. So first we derive our term m, which is this one, in terms of y, and this result is the same that if we derive our term n with x, so they are the same, and that is a proof that it's an exact differential equation. The next step is that we have to integrate m, which is this term, and then we integrate it and we have our prototype, but we have g of y. So to obtain g of y, we have to derive our prototype in terms of y, and it comes to this. So then we compare our derivative prototype to the original differential equation term of n, and we have this term, but we're missing this one, so this becomes our g prime. Then we have to integrate that g prime that comes to this term, and finally we add this to our original prototype, and it comes our implicit solution. For this differential equation, we first need to find our integrating factor and then solve it. Our first step is to find if it's an exact differential equation or not. We derive in both terms m and n, and we find that it's not an exact differential equation. The next step is to find if it or mu, but in terms of x or y. So we try to find an equation that it involves only one term, and we can see that in the second equation we have terms in x and y, but in the first one we only have one term, so it becomes our mu of x. And to find our integrating factor, we raise e to our mu of x, and becomes e raised to the x, and this becomes our new integrating factor. And then we multiply ex to our original differential equation to find our new differential equation, which is this one. Then, to prove that it's an exact differential equation, we derive in both terms, and we find that it is actually an exact differential equation. Step is to integrate a term, and we are going to integrate n. So we integrate and we find that is our new prototype, but we have gx, so we derive the prototype in terms of x in order to find our g prime. Then we compare our derivative prototype to the original differential equation of terms of m, and we are missing these two terms, so this becomes our g prime. The next step is to derive our g prime, and becomes this. Then we add this to our original prototype, and becomes our implicit solution. For our final differential equation, first we have to prove that it's an exact differential equation. We derive both terms m and n, and we find that it's not an exact differential equation. So we test it to find if it's a mu of x or mu of y, and we find that it's a mu of x. Then we raise the mu of x to we raise e to the mu of x, and we found that x is our new integrating factor. We multiply x to our original differential equation, and we have this now as our new differential equation. So we test it again to prove that it's an exact differential equation, which it is. So the next step is to integrate one term. In this case, we're going to integrate n to find our implicit solution. So we got this, but we have g of x in our new prototype. So we derive our prototype in terms of x, and we found this, but we have also g prime of x. We compare our derivative prototype with our original differential equation with the term m, and we're missing this term, so this becomes our g prime. We integrate our g prime, and we have this, so we add the result to our original prototype, and that's our implicit solution.